flux and metal. This metal which is consisting the various pig iron, wrought iron and the ore of the iron. It will be inserted from here in the various pellets or various stages. This is the combustion zone mainly. This is the wind box from where the hot air will be blown from outside towards the inside. This is the only for smelting process, smelting of iron from its ore. Understood? Now moving towards the introduction. Alloys with carbon contained up to 2% are known as steel. हम लोगों ने पहले भी पढ़ा होगा सॉल्वेंट और सॉल्यूट, सॉल्वेंट as well as solute. Okay, this is the major constituent, this is the minor. Okay, when the iron and carbon is mixed and suppose this is the 90%, this is the 2% by weight, and this going to be mixture with each other. Sorry, this is would be a 98%. So that 100% stake will be known as the steel. Up to 2% carbon, up to 2% carbon inserted inside the iron, that would be known as the various kind of steel. The pure iron is having the 0.08% only. Above the 2% of carbon will increase and stands for the cast iron. Various cast irons are there like grey cast iron, malleable cast iron, nodular cast iron likewise, and various kind of steels are there like high speed steel, stainless steel, the low carbon steel likewise. Okay, what is allotropy? What is allotropy? The existence of same metal in two or more than two crystalline forms called allotropy. Iron is an allotropic metal. It has two allotropic modification, which is alpha iron and delta iron with BCC and gamma iron with the FCC. Allotropy, which is mainly two crystalline structure, if we are going to learn this in a simple manner, then it would be like if the we are having the water H2O, whenever we are melting it or vaporizing or boiling or freezing, in the freezing it would be converted into a solid cubical structure. Likewise, in the boiling it would be in the gaseous form, in the melting it would be a liquid form. These three are the various crystalline structures. This is just for an example. So major constituent is the H2O, which is not changing in three different crystalline structures. This would be known as the allotropy. This is known as the allotropic material, and these are the various allotropic changes or modification. Okay. The allotropic transformation of iron is shown here. In this, we are going to hitting the temperature here in the y direction. The temperature increment is here shown here. In the x, the time is shown here: 0 second, 10 second, 100 second, 1000 seconds likewise. So whenever we are increasing the temperature from the room temperature, the first phase where the changes has been happened, this would be known as the Curie temperature, where iron is converted into a non-magnetic phase. Non-magnetic phase. This would be known as the Curie temperature. Remember this, 768 degrees Celsius. Some books are mentioning 765 degrees Celsius. That would be not the uh, topic of discussion. Above the 770 degrees Celsius and the above 885 degrees Celsius, the alpha iron, which is having the BCC structure, body centered cubic, this would be converted into a gamma FCC. Okay, this would be known as the gamma iron and non-magnetic phase. After that, again we are increasing the temperature above 1395 degrees Celsius. It would be converted into a delta BCC structure, again into delta BCC structure. So at the room temperature, alpha BCC, fine. Above the 885 degrees Celsius, gamma FCC, and again above 1395 degrees Celsius, it would be converted into a delta BCC. So a single metal, which is known as the ferrous or ferrite or the iron, which is converted into three different crystalline structure. Remember the above allotropic changes I have taught before this. This would be known as the allotropy for the iron. I hope you all understood this. Now for the cooling curve diagram, whenever we are cooling its or solidification process, the liquid is going to be solid in the reverse manner, where in the heating process this would be in the upper side. In the heating process this would be in the upper side, okay. The main point of discussion is the iron carbon diagram. Everyone just concentrate here. We are going to learn this in the simple steps. Iron carbon diagram. When the iron powder mixed with the carbon by its weight percentage and increasing the temperature, various changes has been happened that would be inserted into IC diagram. Okay, here I have written some steps for IC diagram. The first step we have to learn about the IC diagram is the X direction, where X direction is having the carbon percentage from 0 to 6.67, a gap of 1, 2, okay. The Y direction is having the temperature from 0 to 1600 degrees Celsius. I have mentioned here a 200 gap, so 200, 400, 600, likewise. You have to remember this. The temperature of Y direction, which we have written here, is in the degree Celsius. Okay. Now three vertical line. The first one is at the 0.8 here, 0.8 carbon percentage. The second one is that at the 2. The third one is the at the 4.3 degree carbon percentage. Likewise, the first one is shown here 0.8. The second one is shown here 4. Okay, I have done a mistake here. Okay, wait for a while. Okay, the second one is the at the 2 percentage of carbon. The third one is at the 4.3 carbon percentage. Okay, the three horizontal lines, the first one is at the 723 degrees Celsius. It would be here 723 degrees Celsius. The second one is the 1130 degrees Celsius. Some books or some reference books are mentioning here 1140 degrees Celsius. It would be also same amount, 1140 degrees Celsius. The third one is at the 1493, likewise 1493 degrees Celsius. I hope you have done this, learn this 4 major iron carbon diagram steps to draw the iron carbon diagram. Okay, the next steps are the only temperature mentioning or the various lines we have to draw here. I am just drawing the previous steps here, nothing new in that. The first step which we have learned is the X diagram, X line, 6.67 carbon percentage by weight from 0. The second step is the Y direction, which is having degree Celsius in temperature from 0 to 1600, a gap of 200 to be maintained. The third one is the the carbon percentage, a gap of 1. I have taught that at the 0.8 the first one vertical line, at the 2 the second one, and at the 4.3. So I would like at the 0.8, at the 2, and the at the 4.3. Okay, now the 3 horizontal lines which I have taught you in the previous slide. The first is the 723 degrees Celsius. The second one is the 1147 degrees Celsius. degrees Celsius. And the last one is the 1493. It would be just here, 1493 degrees Celsius. I hope this all you have remembered. Now we are going to move towards this various steps. The first one is the number 5. Okay, the first one is the number 5. So from the 0 and the first point of pure ferrite, 0.0025 carbon percentage in the iron, and the temperature is 910 degrees Celsius. 910 degrees Celsius, the first one. 910 degrees Celsius. Okay, the next one is the sixth number, 0.8. Likewise, now I'm just following the steps. The line number 6, the line number 7 is having here 2% of carbon. Line number 8 is 0.18, somehow it would be a here 0.8, like this, 8 number. Next one is the 1400 degrees Celsius, it would be like this, 9 number. 10 number is 0.08, like here, 10 number. The 11 number will be 1539 degrees Celsius, 1539 degrees Celsius. The 12th number is 12th number line is 4.43. Okay, the 12th number line is from here, it would be passing from this, it would be some difficulty I am facing right now. Okay, now this would be like this, it is just touching here for after the peritectic region. After this it would be 12th number line, and then it would be going towards the 1539, and here the diagram has been completed. Okay, just follow the various steps, you will be learn that it would be very easy. Okay, I hope you have all learned these steps. The first phase, okay, I'm just teaching these are the 3-4 steps. After that the various temperature phases are here. This would be known as the eutectic region, eutectic. This would be known as the eutectoid, and this would be known as the peritectic. These three various reactions asked could be asked in the various examination or the interview, so learn to remember this. I am just having one trick to remember this. Toid means solid. Greek word toid means solid. Likewise, tic means liquid. Okay, now we are in the diagram. Okay, can you see the diagram here, students? Okay, the first phase known as the 0.025 carbon percentage, it would be known as here a Greek word ferrum or ferrite, Fe. After that perlite plus ferrite. After that perlite plus cementite. After that cementite, perlite and transformed laterite will be here. Remember the students, the X 0 to 6.67, on the Y temperature 1600 degrees Celsius, 200 gap, 1000 degrees Celsius. The three vertical lines 0.8, 2.01 or 2, and then 4.3. Three horizontal lines 723 degrees Celsius, 1147 degrees Celsius or 1140 degrees Celsius, 1493 degrees Celsius, 1493 degrees Celsius. Just now, this is the skeleton of the IC diagram. The first line, the second, the third, fourth, 5, 6, 7, 8, 9. The diagram has been completed here. Okay. This would be known as the austenite. This would be known as the austenite conversion, cementite, ladybirite. This would be known as the eutectic. From this liquid, when we are solidifying this, so ladybirite and austenite, this two thing will be after solidification we are gaining. Okay, wait, I am just erasing all the things for eutectic, the various reactions. Okay, eutectoid, toid, that means a solid. Solid 1, that is perlite, and solid 2, solid 1 perlite and solid 2, which is cementite. After heating them, they would be converted into austenite. These both are having the BCC structure, and this austenite is having the FCC structure. After cooling the austenite, the solid 1 and solid 2 will be separated from the austenite. This known as the eutectoid. Okay, the second one is the eutectic. In this, the cementite and austenite, after heating them, they all will be converted into liquid phase. But whenever we are converting this liquid into solidification or the cooling, it would be separated cementite, austenite again. This reaction known as the eutectoid. And the last reaction, which is very hard to remember, this is known as the peritectic. It would be like this. So this point will be known as the peritectic, a 0.18% of carbon, 0.18% of carbon, where delta iron plus liquid, they both on the cooling, remember this, on the cooling, giving the austenite, and whenever the austenite is hitting at above the 1493 degrees Celsius, so it would be converted into delta iron and liquid. This would be known as the peritectic. So these are the various three reactions occur in the iron carbon phase diagram. I hope you have enjoyed this lecture. If you have any doubt, you can ask me. These are the various structure or various things you can learn: peritectic, eutectoid and eutectic. I have mentioned here. Just remember these simple steps, you will learn the IC diagram. I hope these are the various equilibrium phase diagram. I hope you have enjoyed this lecture. I will share this PPT also. Up to 2% the carbon and steel, the carbon inside the steel, which is known as the steel. Above the 2% it would be known as the cast iron. This portion will be known as the eutectic, this portion will be eutectoid, this portion will be known as the peritectic. Okay, thank you so much.